Assalamualaikum warahmatullahi wabarakatuh, and good morning to all of you again. Okay, so in this lecture of 205 integration, we're going to look into the subtopic of integration of trigonometric function. Integration of trigonometric function. Okay, we're going to look into the term of sine, cos, tangent, secant, cosecant, and cotangent, double angle formula, and all that. Okay, so without wasting so much time, okay, so you may refer to your lecture notes in all this one here now. Okay, so we look at the difference between integration of trigo and differentiation of this. Okay, differentiate of sine, it gives you cos. So the integral of cos, it gives you a sine. Okay. The differentiate cos, a function of ax, equal to negative, negative sine, and integral of sine ax equal to negative cos. Okay, so in the differentiate of tangent equal to secant square, so the integral of secant square equal to tangent. Okay, so please remember, we call the result of derivative or differentiate of a function of sine, cos, and tangent, and we also look into the secant, cosecant, and cotangent. Sometimes that kind of question appear, if that kind of question appear. Okay, so differentiate. Okay, this one another three here with cotangent, secant, and cosecant. Okay. Example 1. So then integral of sine 3x dx. Integral of sine equal to differentiate sine equal, it give you differentiate sine give you cos. Integrate sine, it give you negative. Integrate sine equal negative cos 3x divided by derivative of 3x. Derivative of 3x equal to 3 plus c. There you go. Differentiate sine. Differentiate sine x, it give you cos x. Okay. Derivative of cos x, it give you negative sine x. So the integral of sine x, it give you negative cos. Okay, what about this one here now? Integral of cos equal to sine pi minus 2x. Okay, and then integral of cos, it gives you sine divided by, okay, now it's time for us to look at this one here now. Derivative or differentiate pi minus 2x. Yes, pi is a number, is a constant, and differentiate negative 2x equal to negative 2 plus c, where it is a negative sine pi minus 2x divided by 2 plus c. Okay, what about this one here now? Differentiate tangent. Okay, differentiate tangent x equal to secant square x. Derivative of tangent x equal to secant square x. So oppositely, integral of secant square, any function here, it gives you tangent 2x divided by 5 and divided by derivative of 2x divided by 5, which is 2 over 5 plus c, that is that 5 over 2 tangent 2x divided by 5 plus c. Okay, next, to integrate integral of sine square ax dx and integral of cos square dx, we have to use the identities of sine square A equal to 1 minus cos 2A, and cos square A equal to this one here. Okay, if not mistaken here, it is from cos 2A. It is okay, so if I'm not mistaken, that is all come from here. Cos 2A equal cos 2A or x equal to cos square x minus sine square x, where we can make some adjustment here. We still remember that we add up with something with a formula, this formula, sine square x plus cos square x equal to 1. So then from cos 2x equal to 1 minus sine square x, and also sine square x equal to 1 minus cos square x. So we substitute cos square with 1 minus sine square, substitute this one with 1 minus sine square, so you come up with 1 minus 2 sine square x. And also we substitute sine square x here, so 1 minus cos square x minus, in bracket of 1 minus cos square, you come up with 1 plus 2 it is something we call 1 minus sine square x, and this one is 2 cos square x minus 1. Okay, so cos 2x, let's change it into x here, and cos 2x. Okay, we get this one here, and also this. So from this formula, cos 2x equal to 1 minus sine square x, then we elaborate to get this one here. And cos 2x we call 2 cos square x minus 1, then we elaborate until we get exactly same as this one here. Okay, that's not the point of our discussion for this topic of integration, but just to refresh our previous knowledge on the topic of differentiation. Okay, now with this one here, example 2, find integral of sine square x and also integral of cos square x. Okay, so for this one here now, it is integral of 1 minus cos 2x, okay, and divide by 2 dx. Okay, so 1 over 2, take it outside. It is 1 over 2 integral of 1 minus cos 2x dx, okay, equal to 1 over 2, okay, integral of 1 respect to the x, it gives you an x, okay, minus integral of cos sine 2x and derivative of 2x, it gives you 2 plus c. Okay, so if I expand this, you come up with 1 over 2x minus sine 2x divided by 4 plus c. So this is the solution for question solution of A. And what about this one here now? Cos square 2x dx, it is an integral of 1 minus or 1 plus cos 2, okay, because we're talking about sine square x, so we have cos square 2x, so just imagine that these 2 and x are separate. Value here, cos 2 in bracket of 2x, and divided by 2 dx. Okay, so 1 over 2, take it outside here, is a constant integral of 1 plus cos 4x dx, and it is 1 over 2 integral of 1 dx equal to an x plus integral of cos, it give you sine 4x divided by 4 plus c. Okay, so it is a 1 over 2x plus 1 over 2 times 1 over 4 here, which is sine 4x divided by 8 plus c. Okay, so 1 over 2, 1 minus cos 2x, and into 1 over 2x, integral of cos, it gives you sine 2x divided by 2. So the next, integral of, integration of sine ax cos bx dx, and or this one or this one here. Okay, for this case, we have to use all these three. Okay, so as I can say from my experience, that when given this kind of question in a final examination or mid-sem test, they will provide with all the formulas, because we all know that students cannot remember all the formulas of the trigonometric functions. So they will provide all the formulas to help the students using, we call the formulas in the questions that here. Okay, so next, integral of sine. Okay, for question A, integral of sine 3x. Oh no, there's no addition or plus here. Okay, sine 3x, sine 2x dx. Okay, it is equal to negative 1 over 2 integral of cos 3x plus 2x minus cos 3x minus 2x dx. Okay, so it is now negative 1 over 2 integral of cos 3x plus 2x, 5x minus 3x minus 2x minus cos x dx. So then it is a negative 1 over 2 integral of cos equal to sine 5x divided by 5. Okay, minus integral of cos give you sine x divided by 1 plus c. There you go. Okay, for question B, next. For question B, integral of sine 4x cos 2x dx equal to 1 over 2 integral of sine 4x plus 2x plus with sine 4x minus 2x dx. Okay, so 4x plus 2x sine 6x plus with 4x minus 2x sine 2x dx. So 1 over 2 integral of this, integral sine, it gives you negative cos 6x divided by derivative of 6x equal to 6 plus with integral of sine another of, okay, sorry here, integral of sine negative cos 2x divided by derivative of 2x equal to 2 plus c. Okay, you may expand it, multiply this 1 over 2 with every single term we have here 1 by 1, expand it and simplify, or you may just leave it like this. Okay, next, so integration of integral of sine ax cos ax dx, then we have used, okay, sine 2a equal to 2 sine a cos a. Okay, so then sine ax cos ax is where we used it here. So what about these two? Bring to the side and become multiplication of 1 over 2. Okay, so integral of sine ax cos ax equal to 1 over 2 sine 2a. Okay, so then the first one here, where a integral of 2 sine 2x cos 2x dx equal to integral of this one here sine 2x dx. Okay, so it is now integral of sine, it gives you negative cos 4x divided by derivative of 4x, they give you 4 plus c. Actually, this one we can write down as an 4x, just to show you that it's a sine 2a or sine 2a here, where a equal to 2x. Okay, question B, integral of sine 6x cos 6x dx. Okay, so this one here now, it is 1 over 2 integral of sine 6x, or not 6x. Okay, sine 12x dx. Okay, it is 1 over 2, and then integral of sine, it gives you cos 12x, integral of sine, differentiate sine cos, integral of sine equal to negative cos 12x divided by derivative of 12x, yes, 12, plus c, where it is at negative 1 over 24 cos 12x plus c. Okay, so these are all the formulas that you need to remember, but I think that most of the time they will provide with you all these formulas in examination, maybe. So this one here now, integration of trigonometric functions. So please look at this one here and try yourself. Okay, please do not just watch the formula and without trying and make an exercise, because you can easily get forgotten all these formulas here. And these all a few questions as an exercise, and the final answer given to you. I hope that all of you may try the questions before you continue with your tutorial and past year questions. That's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.